Quality assurance measures are essential in the wire bonding process to ensure the reliability, consistency, and performance of semiconductor devices. By implementing rigorous quality control practices and inspection techniques, manufacturers can maintain high standards of bond quality, minimize defect, and enhance overall process efficiency. Here, we explore the key quality assurance measures in the wire bonding process. One of the primary quality assurance measures in wire bonding is the implementation of inline monitoring and inspection systems. These systems utilize advanced imaging technologies, such as high-resolution cameras and laser-based inspection, to assess bond quality, wire placement, and potential defect in real time. By continuously monitoring the bonding process, manufacturers can promptly identify and address issues, leading to improved yields and consistent bond quality. Furthermore, the use of automated bond control and monitoring capabilities in wire bonding equipment is a critical quality assurance measure. These capabilities enable precise control over bonding parameters, such as ultrasonic energy, bonding force, and bond time, ensuring that each bond meets the specified quality criteria. Additionally, real-time feedback and data logging provided by these systems allow for comprehensive process analysis and optimization. Process validation and qualification are integral quality assurance measures in the wire bonding process. Manufacturers conduct thorough process validation to ensure that the bonding parameters and equipment settings are optimized for the specific materials and configurations being used. Qualification processes, including bond pull and shear testing, verify the strength and reliability of wire bonds, providing assurance of their performance under various operating conditions. Establishing standardized operating procedures, SOPs, and quality control protocols is essential for maintaining consistent bond quality and process reliability. SOPs outline the precise steps and parameters for the wire bonding process, ensuring that operators adhere to standardized practices. Additionally, implementing comprehensive quality control protocols, including regular equipment calibration and maintenance schedules, contributes to the overall quality assurance efforts. Collaboration and knowledge sharing among industry stakeholders also play a vital role in quality assurance. Sharing best practices, industry standards, and lessons learned fosters continuous improvement and innovation in wire bonding processes. Furthermore, engaging in collaborative efforts to address common challenges and develop industry-wide quality benchmarks contributes to the advancement of quality assurance measures in the semiconductor industry. In conclusion, wire bonding process quality assurance measures encompass a range of techniques and practices aimed at ensuring the reliability and consistency of wire bonds in semiconductor manufacturing. By leveraging inline monitoring, automated control, process validation, standardized procedures, and collaborative efforts, manufacturers can uphold high standards of bond quality and contribute to the advancement of the semiconductor industry.